we will get underway. All right, so welcome everybody. Good to see you guys here. We're gonna start today. Kate's gonna jump on in a little bit and talk to us about some things going forward with SEAS. We want to talk a little bit about the presentations, and then maybe from that presentations or from some of your takeaways, what do we want to do going forward with the survey? And with the project overall going forward, we want to start to put in some new expectations and kind of different different methods, just so we're staying a little more organized and we're all communicating better. And Kate will touch on some of those things in just a little bit. But otherwise, yeah, mostly today is about going over some of the basics with the survey moving forward. So really today is going to be a lot about laying some groundwork. And so, yeah, Kate's jumping on, so she can jump in and start talking whenever she's ready. But once Kate's done, we're going to do a little bit about the presentations and have some fun kind of setting the course for the survey going forward. So with that, Kate, if you want to jump in, feel free.
Yeah, hi everyone. It is good to see you all, and small but mighty group. So I have always let you know that my main job in this whole process is to make sure that this program is funded. And so we have, over the time period, we've asked for certain things to be done so that I can raise money, and we've been pretty successful. So we have some support coming in to make the SEAS survey, help the SEAS survey move forward, and also have some Dark Skies Education Office things happening here at Glass. So as we do that, this is also calling for a little bit of restructuring. So in the next month, I'm going to get out some new criteria and some things that we're going to need to do. So in order to satisfy the funding, we have to do a little bit of restructuring. The people who've been regulars on the SEAS survey will have a chance to go forward. That survey is going to move much faster. And then everyone else who needs a more informal or more flexible a platform or place to be and do work are going to be working on a different project. So what we're going to need to do, just as a heads up, that's what's going to be happening. And we're really looking for that core group of people who want to have an experience, a scientific experience with the goals of the survey, so that we can use those resources and satisfy our funding. So be prepared for that coming through. And those of you who are on the call, one of the things we're going to need from you is we're going to need a resume from everybody. So in the next 4 weeks, if you don't have a resume together, get that done. And I'll give you some more information on that in a week or two. But I know that that's one thing I'm going to need is a resume. And if you haven't made your profile on the Google Classroom, you need to do that as well. So in that slideshow where you introduced yourself, if you're not there yet, make sure you get there in the next 4 weeks. That'll be part of that process, because I need to send that information to our funder. All right. I know that's not a lot of information, just a heads up that some changes are coming. Okay.
Thanks, Kate.
All right. Get ready, because it's going to be science-y.
Yeah, we're going to be moving a lot faster now.
Yeah, and it's going to be with just the group of people who either have the time, have the career goals to do that. They're going to be in that. Not that we're not going to kick anybody out, but it's just we're going to partition that off so that we can make good progress on that survey, because it's going to be really important to keeping the funding. Okay. Anything else? Okay, I'm just going to hang out in the background here and do my paperwork. I'll listen today for a bit. You guys have fun.
Thanks, Kate.
Awesome.
Yep, bye-bye.
All right, so now moving forward, one thing we're gonna have to do is make sure that everybody goes back and watches this recording that wasn't here for this part, because we really want to make sure everybody's on the same page with that. And I know some of this is going to be in the meeting notes. So if you just happen to be talking to anybody else that you know in the project, make sure just say, hey, you caught the updates, right? Because we want to make sure everyone's on the same page so nobody's surprised when things start to look a little different. But for today, let's jump into the slides for today. So if we want, I can just share my screen, or we can each share our screens with our slides. What do you think would be the best way to go here? Let's see. So I know, Jude, I saw your takeaways were up. Would you like to share your screen and share your takeaways from the presentations?
Can you hear me?
Yes, we can hear you.
Okay. I don't think I can share my screen.
Okay, I'll share my screen
so
for you.
If yes, zero.
Yep. So all right. So go ahead.
Okay. First of all, after like I said on the last point, that many of my other takeaways are in form of questions. I have other things, but many of them are in form of questions, so I decided to not put them up there, of course. And but I'm going to ask them maybe later, or ask Adam. I think I already messaged him on WhatsApp, but I haven't checked his reply. So from what I got on one of the videos, from the first point, we detect black holes in surveys through gravitational lensing, and we can look at local signatures of black holes and compact objects So I think from what I don't know if that was Eric or the other guy. I don't remember where I got this from, but we could be looking out for, like what he said here. We could be looking out for black holes and maybe signs of things like that, massive gravitational objects, through our uh, observations and the survey. So then the reference from regular variable stars, okay, then sorry, that was difference. So here I got that the difference between these black holes or the compact objects and other variable stars we could be seeing in the sky is that they do not repeat, and he explained what he meant by that, and they are achromatic. Then possible searches we could do from this kind of survey is survey of globular clusters, variability of stars, and globular clusters, and micro-lensing events, like mentioned earlier. Then on the survey strategy, there were about 7 points listed, but then uh, I didn't see need mentioning all of it. From ones listed, I noticed and saw that if simulations were made, like if there were things like, though my problem right now is that I haven't really joined a survey before, yeah, but that we've been doing, which trying to do that, but most of the time it doesn't match with my timing. So I was wondering if possible that there could be simulations that could show how these things were done, so that, because in general we, like I will speak for myself. I don't really know about some other persons. I don't know if we could do these surveys ourselves. Like myself, I don't really understand how these things were done, like the usage of the telescope, because I haven't really used it before, or used the command line. I've checked and understood the basic commands there, but then I haven't applied them. I haven't joined the survey. I think so. That's the problem. So simulations might help, and then we see what are being done and maybe follow up when observations are made. in return. Then the metric, I asked that I didn't get all that was said there because maybe I didn't check it thoroughly, but then I didn't get all that was said on metric. Then hourglass plots. Then this seemed the hourglass plots he showed on the papers and on the slides look the same or similar to what Adam once showed us during the meeting. It's been a long time, but then he showed us how to use, I think, Stellarium to see how observations could be made during uh, or when best to make observations. I don't know if he used the plot, Adam. I asked that maybe he repeats that because I liked it the way all he did, but then I didn't really get everything then. Then I have a lot of questions here, plenty of them on survey. I wrote down. I don't know if there will be time for it, but maybe later I will go through that or with Adam later on WhatsApp. I don't know if that is if time doesn't permit for
So
today.
yeah,
Right?
let me
Thank
jump
you.
in here quick. So
Uh,
Jude, I would love to actually go over your questions in just a second. I think some of the questions you might have might be questions that others have as well. So this is really meant to be a discussion and talking about the survey going forward. And we do want to make sure everybody kind of has a good understanding of what we're doing. So I can show you a cool example of what might help you better understand how this telescope is going to do the survey. We did a little mosaic of the Leo triplet, which is 3 galaxies that are just similar to each other visibly that you can look at through a telescope. They're really cool looking galaxies. And so I did a mosaic where I took 9 images and then stitched them together. So I can show you the results of that and how I planned it. So we'll do that after we're done talking these takeaways, unless, do we think it's, I think we'll just wait till after everyone's talked about their takeaways, and then I'll go through that because it might relate to some things that other people have said. But yeah, so the planning the survey, yeah, I think you're referring to when we printed off the sky charts and we plotted out what was visible when, how much of the sky we could observe. And yes, that does feel like it was a very long time ago.
yes, yeah.
COVID has really made this feel like a long year. So yes, that was a while ago, and it's very similar to something that we've done in the past. So digging those up and looking at those again might be useful. I know, I think if you scroll to the bottom of these actual slides, you can find examples that we did and went through. So we might jump into that later on today too. And yeah, you had some of the very similar interests that I did from the first talk. And so maybe that's something we can talk about as a group. But yes, so the simulations is definitely something we should all be looking at. It was something Dr. Nielsen stressed as being very important when trying to optimize your observations. So that is definitely something we'll look at. And after everyone's kind of talked about their slides, we will look at what it looks like for us planning a survey section and what that looks like. So otherwise, if you want to just jump into your questions, what's the first question that you had? Oh, Jude, I think you're muted if you're trying to talk.
Okay, sorry, I forgot.
No worries.
I think I was saying I wrote them down somewhere and I'm trying to find the paper so that I won't miss out any. But then I can remember some of it while I look for the paper. One of these, the questions I have is about filters, about the filters we use. Because I don't really understand, I just see the filters as different colors as which is maybe view the sky, but I don't know if that is correct. So I don't really understand what filters, because we talk about cadence and workflow and all of that filters, and but I don't really understand what filters themselves are and what their usage. And then I want to also next one that links to that is how we can take deeper images. I don't know, since I'm trying to link this to my project on supernova. So I perceive that if galaxies I mean supernovas could be seen at same time from different galaxies, of course not same galaxy, and that means we require maybe some deep images. And if our telescope, I don't know if it can, since yeah, I think it's an average or smaller telescope. From the presentation,
Let's say point
I
five.
perceive that yeah, that these deeper images could be done using bigger telescopes. So I want to know how we can increase the depth of images while making exposures or observations. So,
Okay.
and then the filters. Yeah.
Let me tackle those two questions while you look for your paper. So the first question about filters. One of the best diagrams for me personally was one that Amanda actually put in the FAQ forever ago. So you can actually see these are some of the filters that we will be planning to be used and the wavelength that they will capture. So essentially, when we're using the R band filter, any light longer than 700 nanometers doesn't get through. We don't see it. And anything shorter than 550, 525, whatever this cutoff is here, anything shorter than that, we don't get it. We're just looking at this one band. And so we're getting just information that is collected in this one and that's a broadband filter. So as you can see, these are actually also the SDSS filters that they use during their survey. So you have the U, G, R, I, and Z. So you'll hear these referenced a lot in other places as well. So these are the bands that you can see. And if you ever go to stoneedgeobservatory.com, you can go to the FAQ, and a lot of the information, especially like the basic telescope information, is here. So if you ever forget, how big is the telescope, or oh crap, what filters do we have? This is a place where you can go and look for them. And the other three filters that we tend to use are narrowband filters. Filter. All right, I'm rolling the dice on this. If I get a, there we go. Okay, so we saw before that with the broadbands, you get these big kind of chunks of the visible spectrum, or in the ultraviolet, or down into the infrared. Here, though, we are looking at very specific ones. So one of the narrowband wavelength, none of the narrowband filters that we have, we actually have 3 of the 4 that are pictured here. So you can see that there's hydrogen beta, O3, H alpha, and S2. It's sulfur too, right? Just looking for a nod from Amanda.
S2.
Okay.
Yeah, sulfur 2.
Sulfur 2, okay.
Sorry.
And so, no, you're good. So you can see they actually represented the color in the spectrum that they kind of fit into. So instead of looking at kind of a section of the visible, a section of light, we're looking at a very narrow, specific type of light. And just by looking at that very specific type of light, we're only going to get the information that related to what that wavelength relates to. So hydrogen alpha, seeing high peaks in that, or something that's really bright in H alpha might be really dim in O3, or vice versa. And it really just relates back to the composition of the object we're looking at. So these ones are definitely more for specific uses. The broadband's probably more of what we'd want to concentrate on in the survey itself. But again, that's tied to our scientific goals. So one of the things we have to decide upon is, what do we want this survey to focus on? And that actually brings me to your second question about the research you're doing on supernovae. So A lot of times, even during surveys, they can kind of nix the schedule for that night if something important pops up. So if there's some kind of important event that people need to image and collect data on, you can just cancel what your plans were for that night and go grab that image. So if you're paying attention to any kind of alerts for supernovae in, to be fair, they have to be fairly nearby galaxies. But if you're paying attention to any kind of those alerts, we can check if it's visible to us that night. And if it is, we can absolutely go to that galaxy and image that so we can collect data on the supernova, because A, that's just really cool. B, it provides even more useful data for our survey in the long run. And if it helps you personally, that's an added bonus. So things like that, different events that we want to capture that you'll miss if you don't just stop what you're doing. Those are things that we can do during the survey. So when it comes to supernovae, it's kind of hard to say we're going to focus on it, but it's something that we can absolutely try to include as we go forward, and we can stop whatever we're doing that night to make sure we get it as well. Did that kind of cover most of your questions? The two you asked?
Jude, you're muted again. Can I add on to that a little bit also after?
Please.
Jude, are you still with us? Jude. Chat him.
All right. Jude, feel free to just jump back in if it's a mic problem. Otherwise, you're still muted. But yeah, Amanda, if you want to just add on to what I was saying, I would appreciate it.
Yeah, no, that was awesome. The only thing that I wanted to add on was, he's unmuted again. Oh,
Hello.
go ahead. Yeah.
Sorry, I had a call on the same phone. Sorry.
Oh, no worries.
Okay.
Okay, so did you ask me a question? I was off for a while. Sorry.
Did you
No
get
worries.
any of what Adam said in answering your question?
Yeah, I was here. What was he saying before I left? He was on the site showing me narrowband filter astronomy. Sorry, before
Okay.
I got the call. Sorry. Yeah.
No worries. And you can watch this video back afterwards, but just to quickly catch you up, all I was saying after explaining the narrowband filters is that when it comes to events like supernova, those are things that we can stop our planned schedule for. So if you're paying attention to those alerts for supernova or really cool kind of like, random events in the sky, if you check and make sure that they're visible from SEO that night, we can completely stop what we're doing survey wise and go and image supernova like that, because it just adds some cool data to our survey and also just gives us cool things to look at.
All right, so how do I really check to see if they are visible to the SEO?
Yeah, Amanda,
sorry.
please.
So like there's this one website called rochesterastronomy.org/supernova. Oh, can I share? Sorry.
Yeah. Okay.
So this lists all of the supernova that are active and over magnitude 17, which is approximately what SEO's magnitude limit is. So for example, there's one that is a type 1a supernova that's called 2021 JAD. And if you click on it, you can see it was discovered April 11th, so only 8 days ago. So we can probably still image it and see something in that region. So this is a good place to see where all of these supernova exist, because you can see that a bunch of them are from 2021, like a bunch of them. So if you click on this one, for example, this one was discovered March 30th. This one was discovered March 17th. So there's a bunch that we can actually look at, and a lot of them are type 1A, so you can do really cool stuff with them. So if when we're planning observing sessions, we see that, oh, Jude is leading the supernova working group, and he wants the group to observe like a particular supernova. Just, yeah, like Adam said, you can interrupt like whatever we were scheduled to observe, like if we're doing something not time sensitive, and go look at the supernova that you want to look at. Yeah, as far as like the depth, like how to make images deeper, you just have to do a lot of exposures. Like you just have to observe the same field for many hours, and you can get it deep. I would say that 17 is the limiting magnitude for SEO with like one image, but you can probably stretch up to magnitude 19 with SEO if you do stacks. So it depends on how faint you want to go. The other thing I wanted to mention, kind of adding on to what Adam was talking about with the filters. So I wanted to provide a little bit of physical motivation for why we use different filters. And the reason is that they tell you different physics. They tell you about the physics that's going on at each wavelength. What is wavelength? Wavelength is just the energy that something is emitting, right? So if there is a physical process that is low energy, we would see it more in the red filter. If there is a physical process that is high energy, then we would see it more in the blue filter. So I thought I would show you this like picture of the Milky Way in different filters. And so you can see like in the radio, the Milky Way looks totally different than in the optical versus the near infrared versus the infrared. So it just tells you about, and we can go into this later, maybe when I talk about the photometry slides, but different filters tell you about different processes happening within the galaxy or within the object that you're looking at. So if you look at something with H alpha and H alpha peak is high, like it's very bright in H alpha, like Adam was showing the narrowband filter, that means that there's a lot of star formation happening. So we know that stars are forming when H alpha, when the image is bright in H alpha. If the image is bright in the G band, that means that there are energetic bluer stars in that galaxy or whatever. And so it just tells you different information about galaxies, and you can use that later for a number of things, from figuring out how many stars it's forming per year, to figuring out what the mass of the galaxy is, to figuring out how far away from it is. So using the different filters, you can create a kind of fingerprint of the galaxy that tells us all of this different information. So anyway, those were the two things, the supernovae and the filters.
Right, that was good. Maybe somebody wants to say something before I ask another question relating to this, though. Or should I go ahead?
Go ahead.
Okay, I wanted to ask, with relating to the filter thing and exposure, I wanted to know if the exposure time is a factor for the image depth. Like we say exposure time for hours or days or months. I don't know. Is it a factor to get more deeper images or something?
Yeah, so exposure time is a important variable. And also speaking about the simulations you were talking about, if you just join one of our observing sessions, you're going to pick up how to use the telescope very fast. Like it's very easy. You just have to do it. So on Friday, Adam, I think we were thinking of observing. So definitely join our observing session so that you can use the telescope yourself. Exposure time is important. The problem is you have two options. You have the first option is to take, let's say, short exposures, but then combine them all in post-processing, like add the images on top of each other. The second option is to take long exposures. Usually it is preferable to take short exposures and then stack them later. And the reason for that is when you have long exposures, you have a lot of cosmic rays, which is something that influences your image. It messes up your image. The second thing that you have with long exposures is that you don't have perfect tracking. So the telescope is supposed to track the sky, but if it's not perfectly tracking the sky, you'll see like star trails, like the stars will become like elongated. So depending on how deep you want your images to go, I would recommend that we do a bunch of short exposures and just combine them together later. This is also what Eric said that the Dark Energy Survey does. They would take a lot of short exposures and then combine them together later. But it's one of those things that we can either calculate the exposure time necessary for whatever you want, or we can just experiment and see which exposure time works.
All right, that is good. So one more thing is, if one of the, let's say, I don't know if I should call, say, aims of SEAS is to have a catalog of the entire sky that is visible to the SEO. So I don't know where these catalogs are or how to access previous observations or surveys made. Yes, sorry, Amanda. Right?
Sorry, I
So-
have allergies. Yeah, and
Sorry. So I don't know if you got my questions, or should I restate them?
I think we got them. The catalogs, we're gonna have to make them ourselves. That's kind of the whole point, that we take images of everything and then we make our own catalogs. But that is a little further down the line.
Okay, I was thinking, so what about the other surveys we've made before, observations? Is there somewhere we could access to, maybe to reuse things we already got? As I'm asking.
If you want to like compare to other surveys, yeah, you can use, here, let me show you. There's this one website called Vizier.u Strasbourg. So if you have a particular catalog that you're looking for, it's this website, vizier.u-strasbourg.france. It's made by like some French university or consortium. You can choose the wavelength that you want, so like optical, which mission. So I don't know, let's say we care about Gaia, which is like a star catalog, and then whatever astronomy you want, and then you just click find catalogs, and it tells you, it gives you all of the catalogs that you could ever want that are public. So yeah. So like Gaia data release, for example, go here, and then you can select whatever you want. And these are the identifiers in the catalog. So yeah.
All right. Well, I'll look that up. Can you please copy and paste at the chat? I mean the link, so I can just write it.
Yeah.
Okay. All right. Thank you. Well, one last question, maybe for the. Sorry, I'm taking so much time, I think. So, I wanted to know what was that. Yes, on one of the videos I had on Alex's presentation, he was always mentioning what does color info provide on there. I don't understand what that meant, but I thought maybe everyone has understood that. So can you please explain that? what color info provide on there. I don't know what that means.
Yeah, so maybe it would be a good idea to do like the photometry presentation next week. What do you guys think? Yeah. Okay,
Sorry.
so
Yeah, I think that could be useful.
we can go over all of that, all of those questions again next week, and then hopefully people will have like a better understanding of why we care about filters and what color means in this context. And yeah.
All right, that'll be good. Thank you.
Thanks, Jude. Those were awesome questions. Thank you for bringing those up.
All right, Raphael or Chris, or actually, let me go over mine, and then whoever wants to talk next, let me know, and I'll just go to your slides. Because mine just happened to be under Jude, so it's a nice, easy transition. So, yeah, like Jude mentioned, the something that Dr. Nielsen mentioned, the looking for transiting black holes in very dense star fields sounds really, really cool to me. I don't think it's really that feasible with the survey plan at the moment, but I don't know. That's just something that's going to stick in my brain forever because it sounds just fascinating. So one other important takeaway that I thought was interesting was taking the moon into account for the filters that we use. So the blue filters are only on moonless nights, and the redder filters you use when the moon is up. And you just accept the bias that the moon puts into the redder filters because it's the better way to do it. So I thought that was really interesting because I was always wondering if that was something you have to debate internally, but just having kind of that nice solid answer, just, yeah, this is how you do it, was really kind of cool to me. That I like that. So that's something I took away. One other thing after sitting through Dr. Nielsen's presentation and enjoying that presentation thoroughly was we do need to determine our scientific goals, or at least a couple of them, just so we can really start the planning process. That was very clear. I think he made that abundantly clear in multiple ways. So that was just something that kind of stuck with me, and I think if yeah, we should have plenty of time. So one thing I'd like for us to kind of expound upon, look into, have a little discussion with. Maybe we can even have this discussion offline and Slack, and people can just kind of, you know, shoot ideas back and forth. And the last thing was the optimization process for viewing. I don't know what that kind of coding looks like personally, but it definitely sounds like something that could be kind of interesting, but also kind of complicated. So I'm looking forward to that. I think that'll be kind of cool, the whole optimization process and how we'll go forward with our plan of making our observing sessions as useful as possible, or as time sensitive as possible for us. So those were just some of my big takeaways, and you know, most of them were very overarching to the kind of our planning process, as that's something that's just kind of in the back of my mind anyways, most of the time. So those were just some of my takeaways. Chris or Raphael or Nameka, if you wanna, I know you have to head out soon, but who wants to go next? There's Sunday. Whose were these?
I think they were Peter's.
Oh, these are Peter's. Okay.
Yeah, I checked the edit history and it was his names.
Got it. Okay. So we can skim over Peter's if he doesn't make it on today. Chris, would you like to talk a little bit about yours?
Yeah, okay. Thank you.
No problem.
There was fun actually conversing between my minds, if I have double mind, of dark energy and dark matter. And those were the definitions I took home. Then I was able to see that there are just a kind of a gravitational pull and a gravitational push, a kind of repulsive energy. Though when we talk about a negative, I think somebody said negative energy, and he was about saying is a kind of negative pressure. So I didn't actually know much why he refused using the negative energy word that the person used, but it seems to me that the two are the same or something. Then um, in two kinds of matter, because he talked about some dark matters creating small galaxies, while some large matters create large galaxies. And so in that case, it means there are two kinds of matters, which I actually just checked and discovered they were cold and dark matters. So depending on the cold itself, means is a kind of atoms, or let's say anything that this dark matter must have been made of. So the kinetic theory or the kinetic energy they have when they are being heated up, as they have much kinetic energy, they create high temperature and they move very fast. So as they move very fast, the coalition or their coming together will be difficult, and thus they don't form much heavy bodies like heavy galaxies or something. Then those ones with a hot and that are called hot matter or hot dark matter, the cold dark matter, they have a low vibration. That's the kinetic theory is one. They form a huge galaxy. So, and he was able to say that we can observe these galaxies in different ways. I feel that gravitational or microlensing, the rotational speed of galaxies and mass to light ratio will be more accommodated by the large dark matter, because since they are large, they have large masses, they will be able to create a high rotational velocity, and their mass to light ratio will be high too, and they will create a very strong bending of the fabrics of space and time. So, and with that, we will be able to see the strike of the light. So that was about that. So it will help us to actually know what to do if we are about targeting a hot dark matter site or a cold dark matter site. It will help us in our observation to know which kind of a telescope or camera we are going to use in such region. So if is a place or a point in the space where we have small galaxies, then maybe those galaxies will be faint and we will need a large telescope that will capture at a very short time and go deeply. So we'll be able to see the faint objects. So in considering how far we can go with a dark energy survey and dark matter survey, we may decide to consider the volume. If like when we want to go into survey, you need to consider if you want to cover the whole, maybe a large sphere or a large area, or you want to cover a small area, maybe you feel like you are targeting a supernova and you already know the galaxy or the position, so there may be no need to cover much area. You may just need to have a small volume but a very cool depth. So that knowing what you want to observe will give you a sense of the area and the volume and the depth. So, and it will help you to determine the kind of telescope you may need. So I also learned that sometimes you can, since we know that a small telescope, we have small photons, and they will cover much large area, but they may not go depth. While the large telescope has large photons and we go depth, so there may be need to combine two telescopes if you wish. So there was also a little fun activity that we were talking about whether as the universe is actually accelerating, is it going to stop someday and stop accelerating, or is it going to come back and hit back, and maybe we create an ebb or flow, going and coming back, going and coming back, growth and decline, growth and decline. So and I think Amanda was saying we should watch Time, a movie there. There was a movie you suggested we should watch then that is capturing. But presently we know that our universe is accelerating. So whatever happens then, he said we shouldn't care much about it, that by then we are almost dead. So we may not really necessarily need to think about it. So, and the interesting thing I got from there again was, I was thinking that black holes are just very huge, large mass of body is very huge, that they're always very huge. But when I saw that you can actually get little black holes, like from planetary and asteroid black holes, so I was now thinking that maybe it's just a way of their density being very compact. It can, maybe if I can squeeze a small metal I have in my hand, maybe it's a very tiny dot of maybe a quark, I may say that I have a very small black hole. So my imagination of black hole also changed. So for that of Eric's presentation, that one actually was more, it gave me more trouble to assimilate well. So it just reminded me that I've lost my old astronomy. So the sphere, so and everything, and he actually said it with fun that most times the present astronomers, they tend not to care much about the old astronomy. So, and he reminded us that knowing things about the old astronomy will give you an intuition to do a better science. So he was actually also saying that he listed many things, but the ones I just tried to bring out, the gaming of your matrix. So just like when I was in school, sometimes if it is during exam, you want to perform an experiment, you already know that acceleration due to gravity is 9.8 or 10 meter per second square. So you all manipulate your figure just to get that answer. So he actually said that is not the better science. That metric is just to give you a sense of how to optimize and get a good result, not for you to game your experiment. So the footprint and Candace, it talked about the step by step you need to follow when you know the science of what you want to do. So if you really know that you want to observe a galaxy, so what do you really want from the galaxy? What is the color? What will the color tell you? Are you checking about the temperature, whatever? So you look for the color. Is there need to use filter? So what filter do you think? Is it filter in UV band, B band, or others? So when you know actually the literature of what you want to do, it will give you a better science and a very good step by step of what you want to do. So, and like I've talked about the importance of old school astronomy. So he also talked about us forgetting bookkeeping, that we tend to forget keeping books because we feel we store it in our head, but we shouldn't try to do that, that sometimes it reminds us of what we have gotten and how we can progress. Thank you very much. Do I have questions, but I just kept them. Maybe with time I'll get to ask them better.
Yeah, no, that was good. I think definitely I can, a lot of the things as you were saying, that was like, oh yeah, that was also a really good thing to take away. Um, one second, I'm about to sneeze.
Bless you.
You made my allergies start.
I'm sorry.
I'm blaming you.
My bad.
All right, so, but yeah, so I'd say a lot of these takeaways were definitely good things to come away with. So yeah, so if you want to just ask a question or two that we can kind of touch on now, I think that'd be good. Otherwise, I think we just have Raphael to go through a couple of his takeaways.
Yeah, that was also really good, Chris, like the reminding us sort of things that we really need to like get organized about is going to be important for moving forward. So that was awesome.
Thank you.
All right. Did you want to ask your questions now or save them for observing this Friday? Any
Okay.
preference?
Okay, let's if I think we should ask if Raphael will be presenting. So if he's not, because the questions, I don't know, his discussion, I don't know how long it will take, but so that he'll just present. If there's no time, we have it next session.
Okay. Raphael, do you want to talk about some of your biggest takeaways from the presentations? I have your slides up here if you just want to talk.
Okay, I'll just briefly talk about my takeaway. So while Alex was can you guys hear me right?
Yes.
Okay. So what I could get from what Alex was talking, he was saying mentioned about large telescopes. Say that a large telescope allows you to collect more photons in a shorter amount of time. Um, a large telescope has a very small field of view, which means you can go very deep, but in a small field of view. So same goes for small telescopes. Those small telescopes do have quite a wide field of view, but they can't go very deep. So that's what I could get. And he also mentioned something about dark matter, saying dark matter is extra gravity, saying it pulls things together, whereas dark energy is extra negative pressure. So it pushes the universe apart, and it is the driving force behind the estimated expansion of the universe. So I understood that what this part was actually talking about. And then Dr. Nelson, he mentioned something about the metric being being able to numerically quantify that which is important. And right here, I can't actually start explaining all the what you already talk about. So going to the next one, said is mentioned something over is being a square camera. Even though I couldn't quite understand this particular concept, but this was what I could grab. So he said a square camera with a square field of view aligned RA and D and BC, which is the right ascension and the declination, is relatively straightforward because you can just adjust the spacing and right ascension with declination, whereas in a more complex shape like hexagonal shape, the whole problem becomes a lot more complicated. So this last one is what I could not really grab or fully understand what he was saying. So probably I could get a much more enlightenment here. This last, uh, this last takeaway.
I can that was awesome. I can show you just like a quick, so you know how our camera, when the image comes out, it's like a square, right? But the dark energy survey camera has a camera that looks like, Adam, can I share? Sorry,
You can.
thanks. It has a camera that looks like this. So you see how it's like a hexagonal shape. Hold on. And so what he was saying is that it's a lot more complicated to figure out how to fill the sky when your camera looks like this crazy shape compared to when you just have like a square. So thankfully we just have a square or a rectangle and we can easily like map the sky with that. So that's what he was saying. It's also hard because you see how like each chip has like spacing in between it. So you have to figure out how to cover that spacing properly, but we don't have that problem because we just have one chip. Yeah, that's it.
So why are they using that one if they know it's giving them tough time?
Oh, because it's a lot more powerful. Like they just have like a bunch of chips and it's arranged in like a circle. So here's the camera itself. So they just filled the camera with chips. So this blue stuff is all of the different chips. We only have one chip, right? They have like a lot of them. And so they arranged it like this so that it fits into the circle, and they have many chips so that they can see more of the sky. Yeah. So if you look at like the LSST, let's see if it's like, it also kind of looks, see, they tried to arrange it in a circle, but they like since the chips are square, you can't make a circle out of squares, but you can get close. You can make a hexagon out of squares, kind of. And so they also like use this kind of schema. And the reason they have so many chips is just because you just have that many more pixels to observe the sky with.
Okay.
How cool is that? They took a picture of broccoli. What it looks like in the camera.
Sorry, sorry. So okay, sorry, I have a question. This square shaped telescope, do they have any overlapping issues when you're observing with them or something?
Do they
For
have
our telescope or for theirs?
Probably there, but I don't know, because when he was talking, he mentioned something like overlapping of images when observing with either square or like I couldn't grab quite that concept.
I think this might be where the thing I was going to show earlier for Jude's question is going to come in handy. So let me get that set up. If you want to ask, if there was anything else you guys wanted to ask about, I'm hoping Jude can jump back on, or well, I guess you can watch the recording. So yeah, let me go log into Telescopius. I'm sure Nemeka remembers Telescopius. But it's this really cool tool, and we'll help everybody set it up. But once you have it set up, it's very, very useful. And what we can do is we can actually use it. One of the tools it has is called a telescope simulator. And you'll see why that's important in just a second. Okay. So when it comes to Telescopius, one of the things that is really useful is you can actually put in your telescope. So we have the 20-inch StoneEdge telescope. We have all the details saved in here, so it knows what kind of telescope we're using. And we also have the camera in here. So this is the camera. So we grab the sensor size, sensor resolution, cropping, everything. We put it in here. And then what we can do is go and look for targets. So if we want to catch this section of whatever nebula we're looking at here, this is how you center it like that. And then you just go right here, RA, DEC, boom. You send that into ITSAMNA and you're going there right away. But what we want to do is to take a bunch of images. So when you want to image a large section of the sky, and you want to get that whole nebula, or I don't know, maybe this giant section down here. So this is just a huge diffuse nebula that's really hard to see, and normally you're only going to get sections of it. But this way, if you set out your grid 10 by 10, and so would be, we're taking an image here, then here, then here, and so on for all of these columns. And you're just moving the telescope from the center of the square to the center of the square and so on. Now, what is going to happen is you're going to end up with this big image. But what happens is there's still that inherent noise and bias in the camera. And so some of the pixels are just going to be bad values and aren't going to be that useful. So we have to do what's called dithering. And so you want the telescope, instead of just being edge to edge, so you can like stitch them together, you want them to overlap a bit. So your field of view is going to decrease, but what you're going to do is you're going to increase your resolution because you're going to have twice the data in these overlapping areas. So the more you overlap, the better resolution you're going to get in your data. So this is how you plan a survey, or at least this is kind of the manual way to do it. You just kind of pick your section of the sky. You then decide, okay, I put in a 20% overlap. So you get all of these little columns and rows of overlap where you're going to have even better definition. And you can go, you can go way overboard with it, and you can have a 70% overlap. So you're really getting good resolution here in the center, and everything's just, you're making sure that none of those bad pixels in your camera are lining up anymore. So you can get those things out of there and just improve your data quality altogether. As you can see though, the more you overlap, the less of the sky you're imaging. So that's another one of the trade-offs that we have to look at is with our observing plan, what is our plan for dithering? How much do we want to nudge the telescope every time? Do we want to have set RAs that we just go down a list? Do we just want to have a plan where we nudge the telescope? So nudging essentially just the telescope moves in one or two directions, a small amount. That way you're taking another image of essentially the same field, but it's now slightly off. So that gives you that better increased resolution. Amanda, anything you want to add here?
No, that was awesome. You should show the Leo triplet.
Oh, yeah. Is it 65? No, 66. So, yeah, we didn't need to do this batch. So we went and grabbed the Leo triplet, and I think I had a 40% overlap just to really try to get some nice overlap on here. As you can see, these are three really cool galaxies. And so not this past Saturday, but the week before, we didn't give you guys enough of a heads up. It was a little impromptu. We wanted to jump on, and I just wanted to have a target ready to go so we could have something to image. So we got this prepared, and let me find where. Where is it? GDAN Leo? No. I want to say I just saved it in downloads. Here, let me look for this for just a second. Oh, I see. I found it. I remember why it's where I found it now. Ah. So, oh yeah, one thing I need to go back and redo is the right side, or the images aren't actually square. So some of these have rows of dead pixels because the image they were expecting was shorter than it was supposed to be. So that's just user error at this point. The best way to do this is just in Z scale. And you can see here's one of our galaxies in the Leo triplet. Here's the other. And right up here is the kind of small pencil galaxy. You can see why this is an NGC object and these two are Messier objects. Much brighter.
Yeah,
so
after processing that image will look a lot better.
Yes, and so there you can see the difference. But that's how we were able to plan it out. And you can see it actually lines up pretty well. I think maybe I had less overlap in the actual RA index that I put out. But oh, also this camera is this chip would be a slightly different size, so that probably affected it as well, just because this camera's different. But yeah, so this is an example of what mosaicing and dithering does for you. As you can see, the sections that are overlapped have a lot less noise. Not no noise, but less noise for sure. So you can see down here where there's no overlap, quite a noisy image. And then up here, a lot clearer. You can really pick out where the stars are. The galaxy is quite obvious. And you can even see where this kind of continues, but gets noisy. So that's what we're trying to maximize, is how much dithering can we do while also, actually getting a significant portion of the sky. And this is part of the reason that smaller telescopes typically don't do surveys, because it's tricky. And part of why we're doing it, because it's fun.
I like that explanation.
What time are we starting on Friday? That's a good question. So we can't really start observing until about 11 p.m. Here in Central Standard. So we're 6 hours behind you guys. So that'd be about 5 a.m. for you. So anytime after 5 a.m., feel free to jump on, and we'll have, and we'll be on. If you have plans, if you think of something that would be cool to image on Friday, variable star, anything, and you want to check if it's something that's visible, shoot us a message on Slack. Otherwise, I'm going to be finding something that I find cool, and we're going to be imaging it. So if you want to find something that you find more interesting, you've had your warning.
Jude, the supernova.
Start earlier because of the pep talks. Yeah, and I will plan to be on by 10 at the latest. And anybody that jumps on earlier, I mean, if you guys are good to get up at 4 a.m. and start talking astronomy, more power to you. I don't know if I could do it personally, but we'll be up and we can start talking about answering some of the questions that we weren't able to quite get to today. Yeah, so we have another 15 minutes, and I'm happy to talk about anything else survey related. So one of the things we talked about, and I swear I'll stop talking so you can ask questions soon. So one of the examples is like with supernova, that's something that can't really be one of our scientific goals, or shouldn't be one of our scientific goals, but is definitely something we can include and have kind of a priority list set for when it comes to, if it's visible for us, we go get it, because that's just cool, it's useful, and it just kind of keeps things fresh as we're going through this survey. Because when you're doing a survey, you're not always going to have a galaxy or a nebula in your field of view, and it might not always come out as the prettiest pictures. So sometimes going and shooting a supernova keeps things interesting and fun. So think of some of those other things that kind of get you guys excited in astronomy, and just kind of throw them out there to see if there's something that can be included as a scientific goal for our survey.
Yeah, and one of the things that I talked to Al about this too, Al is like a professor who, he's a professor at UChicago. And I told him a little bit about the survey stuff, and he was like, one thing that he recommended was to have like a test field, like to always have one field that you can like use as like a quality check. For him, he has taken like thousands of M3 images. And I think he like always goes back to that to check like how the telescope is performing, because if you have one field that is, that you are always taking images of, you can see what changes both the atmosphere and the telescope and the CCD are going through. And so it's a good way to calibrate your images that you take later as well. And another thing I wanted to mention is that as we progress into this, we should be observing every day that other people aren't, and they don't observe very often. So we would have like most days to observe. So we should start thinking about like survey strategy in general and having you guys observe while we're sleeping, because you can like get up at 8 or 9 a.m. and it's going to be really late here for us. But once you learn how to use the telescope, you can just jump on and take some images by yourself. So that's something that we should start thinking about to get a move on mapping the whole sky.
That's great.
I have a little question.
Mhm.
You could maybe for some other time, or maybe briefly say uh, what it is. So I just want to know if there is a way um, of knowing what galaxy or what constellation is on an image without really like having a previous idea that this was what was imaged. Like, is there a way software or something that you could know what galaxy or constellation it is if you never knew before?
If are you referring to like if you just have an image back and you don't know where that image was?
Yeah,
Is that
so
astrometry can do that, right? Okay. Do you want to talk about astrometry?
Do you want to do it?
Sure.
uh,
So there's a site called astrometry.net, and it's really, really cool. You can literally take any JPEG or picture of this night sky, upload it, and it will solve it and tell you exactly where that image is in the sky. And it's just really, really useful and really, really cool. So I would definitely recommend just checking it out. If you want to just download a random image from the star server and go save it as a JPEG or however you want to save it and go try uploading it and see what happens, it'll tell you exactly where it was taken. So you can test it and see how close it is. Should be spot on because it's been pretty spot on for us.
Yeah. Do you want to
uh,
demonstrate the website?
Oh, sure. Oh, no, I always get this person's website. Okay. So here we have astrometry.net. All you have to do is upload your file. Oh, okay, so choose a file. All right, let me go look for something astronomy related. There's gotta be something in here. No, that's got the border that might throw it off.
It's okay.
You think it'll be fine?
Yeah.
Where's that one? Let's just throw it in. Okay, so it'll upload the PNG. You hit upload. Usually you take results within 10 minutes. Okay, sometimes it comes back quicker, sometimes it takes a little longer. It just depends. And so now we just wait, and yeah, it'll eventually get you back your information, your field. There we go. Oh, that's a little out of focus. Let's see. Alex, have you used astrometry.net as well?
Yes, it was not really operational during my time in the observational astro class, so I used the local version of it most of the time. I managed to install it on my computer, but
Oh, cool.
yes, I am familiar. This whole waiting forever is familiar to me as well.
It's like a
Sometimes the
third of
web
astronomy,
version-
isn't it?
Yeah, sometimes the web version takes a long time to solve.
There you go.
There we go. Something's happening.
So click go to results page. Oh, I thought it finished for some reason. Well, so one way to like speed it up too is to like input the coordinates of where you think your center of the field is. it knows where to search that way.
Hmm.
But
What are they trying to? NGC 1924. What is
oh
that?
yeah, look, it like knew somehow.
Where?
It's like in the tags on the right.
Oh yeah, I did.
Yeah, right. It's cool because you can also see community images, like other people who uploaded stuff. You can even take a picture of the sky and upload it into this. I once took a picture of a poster and I uploaded into this and it worked.
That's the coolest story to me.
Right?
A poster here. Let me just take a picture and upload it.
Yeah.
Okay, so it's still processing. Do I have to refresh the page, or will that break it?
Just leave it, but it'll probably process for a while. So I would just, yeah, like this is the website that you can use, and you'll just have to wait like 10-ish minutes and then it'll solve the field and tell you where it is. But we don't have to wait for it to solve it.
Right. But yeah, so Jude, that is a tool that you can use whenever you need to figure out where something was taken, where in the sky. All right, we got about 6 more minutes before we have to start wrapping up for today. Another thing we can do is we'll still have our kind of like open office hours time on Thursdays from starting at 11. So it'd be 5 p.m. for you. So if you can't make that, that's totally fine. But if you do still have questions that you'd like answered beforehand, that's something we can discuss on Thursday. Otherwise, we will be observing on Friday night. And sometimes once you've kind of got what you're observing down, there's a lot of time for conversation. So yeah.
Friday night, is it our morning?
It'll be Saturday morning for you.
Okay, Saturday morning.
Yeah.
Oh, one thing I wanted to mention also is that we've started looking at some of those conferences and fellowships, and we think that some of you should definitely be applying to those. So maybe like sometime very soon, because some of the fellowships have deadlines coming up, we can talk about writing proposals and hopefully getting you guys some like external experience in like a international university or whatever, or a research institute. So definitely applying, at least writing the application will be useful, even if you don't get it. Like it's not unlikely that people don't get it. I've applied to like tens of stuff and I only got like 1 or 2. So it's hard, but it's worth applying to and trying anyway, because it'll improve both like your writing skills and your research statements. And also like it's never a bad thing to try, if you don't knock on the door, then definitely nobody will answer. So I think that's a Russian saying and I translated it poorly. but yeah, so we should start thinking about those. You should go to the events and opportunities channel and see which ones you think are interesting, and we can start applying to those too.
I have something to say about this. I think I've opened that before, and so I saw many of them which involve research and internship there for masters and PhD. But the ones that I could do, we have a problem around here. Getting someone to write the reference for you is a big problem. It's like asking them for money.
Getting someone to write what for you?
reference or
Oh, a
recommendation, it's a big problem, and they are always requesting for that.
Yeah.
And here, you beg your lecturers, they won't even do it. They, I don't know why, but they hardly get to listen to people about that. So it's a problem for me. I don't know about every other person. Maybe they get it easily, but it's not. It's hard here. And then I get a reference, especially ones that were sent directly to the site or organizing team or anything. And then I have to apply for another one, and then it's hard to get someone again, and it's always a problem. So
Is it hard to get someone to write it for you or to sign it? Because one option that you can make, are you an undergrad or a grad student?
an undergrad student.
Undergrad. One thing that you can potentially ask is you can say, if I write the recommendation, will you sign it for me? I don't know if that's
Like I understand. I already did that, but it's also not so working because I already have like one person who admitted to that. Every other person will say long story, but that it's a big problem for me.
we can also we can probably reach out to Dr. Emeka and Prosperi, since they're part of this program. Like, we can reach out to them for help as well to get you guys recommendations and stuff. I think that we can definitely find a solution to this to this problem.
Agreed.
So yeah. So yeah.
Right?
At the
That
very
would be very helpful. It's always a problem. That is where we get stuck most time. The
At the
ones we could do, motivations and the rest, we could always do them. But
Yeah.
recommendation reference, problem. Yeah.
I think we can definitely solve that problem. So as long as you guys are interested in those opportunities, and we can definitely make sure that we get all of the necessary requirements.
Yeah.
One of the things we're planning on doing in the future is going over how to apply for positions like that and that type of process. So that's definitely another thing that we can bring up and really dive into when we get to that.
Also, Kate writes great recommendations, but she's like very you have to put in work, like a lot of work to get a recommendation from her. So, but she writes great recommendations. So we can definitely yeah. Go ahead, sorry.
Yes, that Kate definitely makes you earn it, but boy, is it worth it.
Yeah. Okay, I have another meeting that started a minute ago, so I gotta go.
Bye, Amanda.
It was good to see everyone, and see you on Thursday, Friday, or next week.
Goodbye.
Thank you.
Bye-bye.
Thank you so much.
All right. Thank you, Amanda. Thank you.
All right, and I think I'm gonna end it here.